Hello learners, how are you doing? It's your mathematics teacher, Mourad Sultan Ezouidi. Today you are going to train yourself or to practice the discriminant formula of me, and through this discriminant formula you are going to find the value of x. Okay, so this is polynomial to the power 5. Okay, I'm going to wait for the Word to open. Here we have polynomial to the power 5, and we are going to solve this polynomial. Okay, the title of this lecture is Solve the 5th degree polynomial equation. Okay. I will give you time, learners, to prepare your calculators, scientific calculators, and papers and pens. Okay, so that you can start working with your mathematics teacher, Mourad Sultan Ezouidi. Okay. I'll just close this. Okay, I'll check connection. Okay, so learners, here we have polynomial to the power 5. I will go up. Okay, where is it? This one. Yes, this polynomial you are going to solve, learners. Okay, it's an occasion again to learn from you how finding the exact roots of any polynomial to the power 5. Okay, so these are my polynomial to the power 5, x to the power 5 minus 10, x to the power 4. Okay, let's work. Okay, we told the x raised to the power 5 minus 10x raised to the power 4 plus learners we told the plus what? Plus 40. I will erase this. Plus 40 minus 80, of course x squared, plus 85 x minus 42. Okay, minus 42. Okay, this is the polynomial to the power 5 learners. You are going to work through the discriminant formula of me, and you are going to solve this polynomial with any problem. Okay, let's start. So our polynomial, our let's say 5th degree polynomial equation can be written as P of x equal x raised to the power 5 minus L0 of O dq x4 plus L1 of O dq x3 minus L2 of O dq x squared plus L3 of O dq x minus L4. It's clear that L4 is 42, L3 is negative 85, okay, and okay, and L2 is equal to 80, L1 equal 40, and L0 of O dq equal 10. So you can see this is polynomial to the power 5. We are going to find or determine the values of SR of key relative respectively to LR of O dq, where R belongs to learners to minus 1, 0, 1, 2, 3, and 4. Okay, let's start. This is the coefficient of our original polynomial. L0 equal 10 because this is 10. Then L1 equal 40. I will erase this one. This is 40. Okay. L2 learners equal AD or 80, whatsoever the spelling. Okay. And L3 equal 85. I will erase this one, 85. And L4 equal 42. Okay, this is the polynomial to the power 5, the coefficient of this polynomial to the power 5. Here, learners, you are going to use the discriminant formula of Mourad Sultan Ezouidi HSM. So this formula can be summarized, can be summarized or given you the new polynomial to the power 5, and after that you are going to find out the x roots of this new polynomial. Okay, and as a conclusion, you are going to add these x roots to L0 of O dq and then divide by 5. Okay, it's clear. We start. So this is the discriminant formula of me. Tells you that x subscript k minus 1 of order r equals the sum from 0 to k, combination n minus r, choose k minus r, n raised to the power r between parentheses, negative L0 of O dq raised to the power k minus r times Lr minus 1 of O dq. Always, learners, we are going to use this formula to find the coefficient of the new polynomial. After that, you will write your new polynomial and try to solve it. After solving it, go back to your original polynomial equation. Okay. To find, learners, s minus 1, just set k equal 0 in the discriminant formula of me. You will get s minus 1 of r equal 1. For k equal 1, learners, just substitute in the discriminant formula of me k equal 1. It will give you s1 minus 1 will give you 0. So S0 of order r equal the sum from 0 to 1, combination n minus r, choose 1 minus r, n raised to the power r between parentheses, negative 0 for the q raised to the power 1 minus r times Lr minus 1 for the q. This one, learners, after expanding this sum, okay, we obtain that S0 of order q equal negative combination n times S0 of order q times n minus 1 of order q plus n L0 of order q. This one always, the value of S0 is always 0. Okay? Just I'm going to substitute here, change the coefficient. This is we told 40. This is learners is 10. Okay. This is we told 80. Okay, this is 85. And this one 42. Okay. So, learners, here it's clear that S0 of order Q 0, S0 of order R is 0. Okay, I'll just calculate this and send this if it is possible. Okay, I'm waiting. Yes, okay. Here L0 of order R is 10. I should replace 12 by 10. This is the previous example. Okay, this is 10. So it's clear, negative 5 times 10 is 50, negative, and or below 0, 50, negative 50. Then 5 times 10 is 50. Therefore, learners, negative 50 plus 50. Is it 0? Of course, yes. I will close this parenthesis. Therefore, we calculated, learners, what? We calculated the value of f0 is 0. It means that for any polynomial to the power n, s0 is 0, learners. Okay? For any polynomial to the power n, n0, s0 is 0. And s minus 1 is 1. Okay. Now at least you got the point. How can you find the value of sk minus 1 of order r using, of course, the discriminant formula of me that had been generalized for any polynomial to the power n. Okay? And I wrote so many books about this formula. Not only this, but some other discovery, research, and I published it. Okay? And you can get it if you like. Okay? Therefore, just type on your computer Mourad Sultan Ezouidi, or write polynomial to the power n, theory of polynomial to the power n, or solving polynomial to the power 18. Yes, there is a book that consists of finding the zero of polynomial to the power 18. Of course, using this formula. Okay. And now, learners, we proceed. We continue. We found the value of s minus 1 and s0. Now we are going to find the value of s1. To find s1, learners, just put in the discriminant formula of me k equal to. Okay? Means s1 of order r equal the sum from 0 to 2, combination n minus r, 2 minus r, n raised to the power r between parentheses negative 0 for the q raised to the power 2 minus r multiplied by l r minus 1 for the q. This, after developing this and simplifying, will obtain the last one, learners, which is negative combination 1 choose 1 is 1. If you like to ignore it, no problem. Times combination n choose 2 times l0 for the q squared plus n squared l1. This s1 that is written in terms of combination and l0 for the q and n and l1 is general formula. Okay? And this has been developed by me, of course. So, let's find the value of S1. Okay? Here we have L0 is 10, L1 40, L2 80, and L3 is 85, Mr. Mourad. Okay? And L4 is 42. Okay. Therefore, then I'm going to substitute. Okay? I will substitute or replace L0 with its value and L1 with its value, and then we calculate it. What is the value of L0 is 10. I should write here 10. Okay. And, okay, L1 is 40. We thought, okay, 40. Therefore, I will use a calculator. I will try to use calculator. Sorry, again, Mr. Mourad. I close it without checking. Okay, I will calculator. I will type here calculator so that learners can check with me the value of S1. Okay, we told calculator, Mr. Mourad. Okay, thank you. Okay. Very good. Okay. Good job. Continue. Calculator. Okay. Look here. We have negative combination 5 choose 2 minus 10, negative 10. I will write here, learners, negative 10 times 10 square plus 5 square times 40. I will write negative. What is negative, Mr. Mourad? Negative side. Okay, negative 10 times 10 squared means 100, isn't it? Plus 5 squared is 25. 25 only, multiply by 40. So this one has to be equal to 0. Okay? Therefore, S1 learners is 0. Okay? S1 is 0. We continue. So now we are going to find the value of S2. Just go back to my own formula discriminant formula sk minus 1 of order r equal the sum from 0 to k combination n minus r choose k minus r n raised to the power r between parentheses negative 0 of order q raised to the power k minus r times l r minus 1 of order q. We told just put k equal a 3. It will be s 3 minus 1 gives you 2. The sum from 0 to 3 combination n minus r choose 3 minus r n raised to the power r between parentheses negative 0 for the q raised to the power 3 minus r times l r minus 1 of the q. This one, after developing and expressing this or simplifying this, we obtain the last one, which is 2 combination n choose 3 l0 for the q raised to the power 3 minus combination n minus 2 choose 1 n squared l0 for the q raised to the power 1 times l1 for the q plus n cubed l2 for the q. Okay, I will just find the value of this s2. This one is generalized for any polynomial to the power n. Okay, any polynomial to the power n should pass through these steps. Okay, you should use my theorem or my formula. Okay, now this is the coefficient of your original polynomial. Let's start. So we told that okay, I will use my calculator. This is my calculator. At the same time, learners, try to use yours if you have. Of course, you have calculators. Therefore, I will just write 2 times 10 is 20 times 1000 means 20 times 1000 because 10 raised to the power 3. Okay, minus 3 times 25. 3 times 25 times 10. Okay, means negative 75 times 10 by 40 is 400 multiplied by 400. Okay, plus learners 5 cubed 125 plus 125 multiplied by 80. So this one has to be equal to 0. The value of S2 learners is 0. Okay, we use my general formula, my discriminant formula when k equals 3. Okay, therefore now we found s minus 1, s0, s1, s2. It remains only two values, which are s3 and s4. Okay, for s4 learners, just put in the discriminant formula of many k equals 4. We will obtain this formula. S3 equals the sum from 0 to 4, combination n minus r choose 4 minus r, n raised to the power r, times negative L0, negative, of course, negative L0 for the q raised to the power 4, minus r, times Lr minus 1 for the q. After developing this and simplifying it, we obtain the last one. Okay? Means you are going to expand this formula, you will get this one. Okay, it will be negative learners, negative combination features 1, combination n choose 4, L0 for q raised to the power 4 plus combination n minus 2 choose 2 and squared, L0 squared times L1 minus combination n minus 3 choose 1 n raised to the power 3 times L0 for the q times L2 plus n raised to the power 4 times L3 for the q. Look, n here for n polynomial. If you are going to work with polynomial to the power 10, just put n equal 10. And here 10 minus 3 is 7 and so on. But here in our example, n is 5 because the highest power is 5. I will calculate this, learners. How it comes here. This is the formula. We applied this one. We just substitute L1 and L0 and L2 L3 and L4 with their values. And we are going to replace also n with 5, and we'll get negative 3 times 5 means negative 20. Okay, times 10 raised to the power 4 times 10 times 10 raised to the power 4. Okay, then plus learners 3 times 5 25 75 plus 75 because 3 times 25 times 10 squared times 40 times 10 squared is 100 times 40. Okay. Minus 2 times 125 means minus 250. 250 times 10 by 80 is 800 times 800. Okay. Plus 5 fourth, it will be plus 625 because 5 to the power 4 times 85 times learners 85. This one has to be equal to okay, I check again. Okay, we have negative 3 times 5 times 10 to the power 4. Okay, بعدين plus 3 times 25 times 25 times 10 squared times learners times 10 squared times 40 minus 2 times 125, okay, times 10 times what? Times 80 plus 5 raised to the power 4 times 85. Okay, this one equal 3125, you see? Okay. Sometimes the artificial intelligence, how to say it, can change the values in the calculator. Okay. So we continue, learners. We told that S3 equal 3125. Okay. Therefore, we need to find the value of S4. To get the value of S4, you just put in the decimal formula of mean K equal 5. You will obtain S4 raised to the power R equal the sum from 0 to 5, combination n minus R choose 5 minus R, n raised to the power R, times negative 0 for q raised to the power 5 minus R, L R minus 1 for q. After developing these learners, we will obtain the last formula. Combination 4 choose 1 times combination n choose 5, L0 for q raised to the power 5 minus combination n minus 2 choose 3, n squared, L0 for q cubed, L1 plus combination n minus 3 choose 2, n cubed, L0 for q squared times L2 cubed minus combination n minus 4 choose 1, okay, n raised to the power 4, L0 for q times L3 plus n raised to the power 5 times L4 for q. Look here, this formula S4 has been generalized for any polynomial to the power n. If you would like to solve polynomial to the power, for example, 30, you should pass through this formula. You should find S1, S2, S3, S4, S5, and so on. And its formula is written like that, okay? Of course, according to the K value, okay, that we set here. Therefore, now I'm going to calculate this one, learners, okay? I will just find the value of learners of S4, will obtain 0. 4 times, I will just write 4, times 10 raised to the power 5, okay. Then minus 3 choose 3, now need to write is 1, minus 25 times 1000, because 10 raised to the power 3, times 40, okay, plus learners, plus 5 cubed, plus 125, 125, times 10 squared is 100, times 80, minus 625, times 10, times 85, plus learners, 5 raised to the power 5, times what? Times 42. Okay. Times 42. This one has to be equal to 0. Okay. Now we proceed. We obtain the coefficient of the new polynomial. This is, of course, is 10. Okay. This is 40. The new polynomial, the original polynomial that we worked, that we purposing to find its roots. This is, of course, is 80. This is known as is 85. This is known as 42. Okay. Okay, this is your original polynomial that we started solving it. Okay. After calculating the values of S0, S minus 1, S0, S1, S2, S3, and S4, we are going to write our new polynomial. Our new polynomial, okay, where the roots are called x roots, is px equal x raised to the power 5 minus S0 for the q, x raised to the power 4, plus S1 for the q, x raised to the power 3, minus S2 for the q, x raised to the power 2, plus S3 for the q, times x, minus S4. Okay, just substitution learners. I'll just write this one. We have S0 and S1 and S2 and S4, all of them equal 0, except what? Except S3, which is equal 3, 1, 3, 1, 2, 5, I thought. Okay, I'll check here. S3. Yes, S3 equal 3,155. Okay. Now, just substitution. You can put x as a common factor. X will be x times x4 plus s3 of all the q equals 0. Means x equals 0 or x4 plus s3 q equals 0. Therefore, I'll just write here. Of course, here x equals 0 or x4 equal negative, because this is plus here, you see plus, and this is plus. When you transfer this on the right hand side, it will be negative. It will carry with it a negative sign. Therefore, x raised to the power 4 equals negative s3 for the q times exponential 2ik pi. Therefore, xk, because we have 4 roots here, x4, xk from 0 to 3 is equal to what, learners? Equal to fourth root of negative s3 for the q exponential 2k I pi. Okay, of course, you see this negative sign, you can write it as exponential I pi. It will be fourth root of s3 for the q exponential I pi times exponential 2i k pi. You can add this together. So it will be fourth root of exponential s3 for the cube exponential 2k plus 1 times I pi over 1. Why I appeared here a fraction? Because I'm going to raise it to the power 1 over 4. So 4 will be the denominator. Therefore, this one has to be equal to, I'm going to separate these two things. It will be root of fourth root of s3 for the cube times exponential 2k plus 1 I pi, all raised to the power 1 over 4. That's why here it's written 4 times 1. Okay. Now just substitution. And S3 we told is that. Okay, it will be 3,125. Okay. Minus, if you like here, learners, okay. Yes, S3, okay. So, I will use calculator. I will write root of, or I will write 3,125. 5 raised to the power, okay, to the power 1 over 4. Means 0.25. It will be equal to 5 for 5. Okay, I'll check. 25. Okay. So this calculator can write inserts, mass inserts. Okay, I will use this one. Root, just a moment. Root of 3, 1, 2, 5 equal the same. The answer can be written in sets. Okay. Therefore, this one I will write here. So, okay, I will use my calculator. This calculator, I will try to use it. Okay, I want the answer. I will leave the answer in sets. It will be root of 3,125. It will be okay. Not root. Okay, fourth root. Okay. Root in parentheses. Root of 3,125. So that was 7.4. Okay. Therefore, learners, can you see this one? Look, 5 raised to the power 4 equal. Multiply by 5. Okay, so I will write as that. It will be 5. 5, Mr. Mourad. Okay, 5. Root 5. Check again. Okay. 625 times 5 equals 3,125. Okay, now I'm going to make the fourth root. Okay, fourth root. Where is it? Okay, to the power. And in parentheses 1 over 4. 7.5 approximately. But me, I'm going to. Okay, I will leave inserts. Okay. So root here, yes, fourth root of what? Fourth root of 5. Exponential 2k plus 1i pi over 4. Therefore, learners, the formula, this is the x roots of this polynomial, this one. Okay? Now, the roots of my original polynomial, I will label it as beta subscript k belongs to 0 to 3, which is equal to A0 for the cube plus xk. Xk tells you that it is fourth root of S3 exponential 2k plus 1i pi over 4. Okay, now just I will substitute. So it will be equal 10 because A0 is 10. Okay, this is equal 3,125. We can leave the answer like that if you like, but I'm going to continue. Divide by 5 because the highest power is 5. Okay, this is 10. Okay, plus okay, plus what? Plus 5 root of the plus, where is it? This one, plus 5 root of 5. Okay, or you can leave it as cube fourth root of 3,125. This is depends on you. Okay, therefore, this is the fourth root. We need, it remains only one root. Did you remember that x equals 0? Therefore, beta subscript k belongs to 0 is L0 plus x0 over 5. L0 is 10. Okay, is 10. Divided by 5 gives you 2. Okay, equal to. Okay, so here learners will have these will have only one root, and the next 2, 1, 0. Okay, all these roots will have 4 complex roots. Okay, and we'll have only one real root. Okay, we just write it here, it's better, equal to. Okay, now if you would like to check learners, go back to your equation. I will check that only the real root because this one depends work and development. Okay. Now I will go back to check this one. Mr. Mourad, the best teacher in the world. AK Mr. Mourad Sultan Ezouidi. Okay, I learned. This is the calculator in front of you. We have 2 raised to the power 5 is 32 minus 10 times minus 10 times 16 minus 160, because 10 times 2 raised to the power 4, 2 raised to the power 4 is 60 times 10 is 160 plus 40 times 2 raised to the power 3, 2 raised to the power 3 is 8, 8 times 40 is plus, we said it, plus 320 minus, we told 80 times 2 squared. 2 squared is 4. 4 times 80 is negative, we told negative, negative what? Negative 80 times 4, negative 320, because 80 times 4 plus, learners, what? Plus 85 times 1 means plus 170. Oh, sorry, 85 times 2. Okay, 2 times 85 is 170. So plus 170. Plus 170. Minus what? I will make just equal sign to get the opposite sign of this. Or I will continue to make minus 42. Minus 42. This one is equal to 0. You see, this is your mathematics teacher, Mourad Sultan Ezouidi. We reach solving point to the power 3, 4, 5, 6, 7, 8, and continue, but the problem is time. Sometimes one lecture depends 1 hour or something like that, or more than that, okay? Okay. Don't forget to go and buy my books, learners, okay? It's very important for you. Okay, or just send me a message, an email, I will send you a copy. Okay, of course, if you'd like to buy from Amazon or from me, whatsoever. So just type Mourad. My address email is Mourad Sultan Ezouidi .gmail.com. Just type this on your mail and send me. Okay. Okay, Mourad Sultan Ezouidi @gmail.com. Okay. Thank you for listening, learners. I will just save this. It is possible, learners. Okay. Now, we'll check if GeoGebra can solve this problem by a graph, of course. Okay, GeoGebra. Yesterday I gave him a question, he can solve it. Okay. Okay. GeoGebra thought. Okay, thank you. GeoGebra, Mr. Mourad. GeoGebra. Hi, Mr. GeoGebra. Come to your ankle. Hi, Mr. GeoGebra. I wish that lecture was clear for you, learners. This is Mourad Sultan Ezouidi, the pioneer methods, the Tunisian researcher in the field of mathematics, and he got so many books and he published so many books deal with solving 2 to the power n. Okay. GeoGebra classic software. Hi, Mr. GeoGebra. Maybe he will use the method of remainder theorem. Okay, but he can find the others. Okay, let's check. X raised to the power 5 minus 10 x raised to the power 4. Okay, plus 40 x raised to the power 3. Okay, yes. Minus 18 x squared. Okay. Minus 80. Yes. Plus 85 x only minus 42. Of course, it has to be equal to 0. This is my equation. x4 the same as that, you see. x5 minus 10x4 plus 40x cubed minus 80x squared plus 85x to the power 1 minus 42. Okay. Out in here, please. I will tell it. Solve. Okay. Of course, he used, let's say, the intersection of the curve with the x-axis. Okay. Here the artificial intelligence and algorithms works. Okay. So he got only 2. Okay, because it's clear he used the main theorem. Okay. Of course, here you see. So, but the others you can't solve them. Okay. So we continue, learners. This is your mathematics teacher, Mourad Sultan Ezouidi. No, cancel. Leave. Now we'll go back to this one. Of course I can. This one خلاص. Thank you for listening, learners, and I wish that everything is clear for you. Okay, I will stop now. Stop streaming, and goodbye. Thank you. Stop recording, of course.